Okay, so today we'll be talking about exponential growth and decay, and basically exponential growth and decay we'll be using this form, except instead of x we'll be using t as our explanatory variable, which just basically means our independent variable that controls everything else. Okay, in exponential growth and decay, you either have a decay factor or a growth factor. There's still going to be the same number b as what we learned last time. Okay, but in exponential growth, b is going to be between 0 and 1, and you learned that when that graph happened, we had a graph that looked like this, something that looked like that. Okay, and then in exponential growth, it's just your typical exponential function that goes up like this. Okay, all right, so this is just the form you'll be using, and expect x to be replaced with t. Now, if we expand that a little bit, if you notice, this takes the place of b, this takes the place of just t, and this takes the place of a, you actually are given the compound interest. Okay, and P actually stands for principal. I like to call it the beginning amount because you could also apply this to exponential growth or decay as well with the social sciences. Okay, but A is the total amount at the end, B is the beginning amount, R is the rate, and you do need this in decimal form. If you do not have in decimal form, that's going to be a huge issue. Okay, and it is going to be a decimal form, and yes, you are going to be dividing that by n. Okay, and I'll show you later on Desmos how to actually do it. Okay, and then in your exponent, you're going to have n times t. Now, n is going to be the number of times you compound your bank account in a year, or the number of times the bacteria grows, you know, that type of thing. And then t is going to be time in years. And let's go to Desmos now, so I can show you how this looks when you type it in. Okay, so let's start setting up. So I go y equals, let's say our principal amount, let's say 3,000. Okay, and let's say it was a car. So car, let's say is depreciating. So it's depreciating, let's say 35. No, let's say not say 35%. Let's say 13%. So you would have put in a second set of parentheses in here 0.13, and then you would divide that by, let's say it depreciates every month. So there's 12 months in a year, so you would put a 12 here. If it was weekly, you would put 52. Okay, so it's simple as that. All right. Now, since it's depreciating, you are going to actually make this a minus type problem. Okay, and you'll understand why in a sec. Now, out here, you would put in the exponent. You would have, let's say, 52, and let's say over 3 years times 3. Okay. All right, so let's say you bought a car for $3,000. The depreciation rate is 13% every month. And let's say after 3 years you want to sell it. How much can you sell it for? Okay, all right. So you can see right here that it's just going to be a straight line. Pretty simple. It's not going to change too much. Okay. All right. Well, actually, we don't need a graph to actually show that. We could actually show it by the numbers. Okay. All right. Now, if I did want to do the graph, I would change this with an X. Okay. And I could actually see some stuff here. Okay. Now, as you can see, after if I zoom out a lot, it's going to look really kind of skewed to what it's actually going to be. And as you can see, I'm still in the hundreds. And this is going to be a very severe type of thing. And this is going to lose a lot of value after a certain amount of time. So this number right here, this is about after 24 months. So this is after about 2 years. No, this is years. No, I'm sorry, that's years. That's what's going to be depreciation to. So if we wanted to find the actual value in years, we would have to go up higher here. Okay, so if I wanted to figure out by 3 years, I would just set y equals 3. No, x equals 3. And I would just find the intersection of the two. Okay, and you would have to go quite a bit of ways to actually find it. Okay, and if we click here, there it is. You would find the same answer as what we just did if we didn't have that. Okay? All right, so you can also find it graphically, and you could actually find the actual answer by just plugging it in. So that's the beautiful thing about all this. Okay, now obviously that's depreciating at quite a big rate. So let's say you just wanted to over every year, it depreciates by 13%. Okay, so you would just replace, once again, you would replace the 3 with the x. Okay, and you could actually find it again. And as you can see, it's not as severe. Okay, and as you can see, after about 20 years, you're probably going to be selling it for about 185 bucks. Okay. All right, but that's how you actually plug it in. Just make sure you have your parentheses, and if you had your decimal in correctly, you wouldn't see this at all. You would see something really, really horrible. Plus, if you think about this, is 1 minus 13, that's negative 12, and we cannot have this number be negative in here, so you're not going to find that. But if you put the decimal, you'll actually see it. Okay? All right, and that's it for exponential growth and decay. Just remember, if it's decay, you're going to have a minus. If it's growth, you're actually going to have a plus in there. Okay? All right. You guys have a wonderful day, and I'll talk to you later. Bye.